Okay, so this next video is all about current and charge. And so we define current as being the rate of flow of charge. Now, that's also meaning basically how many electrons have I got and how fast are those electrons going around the circuit. Rate, if I ever see that word rate always just means divide it by time, okay? So if I ever see rate, I know I have to divide something by time. So it's the rate of flow of charge. Okay, so it's my charge divided by my time, essentially the electrons. So a high current would mean the electrons were moving around my circuit really, really quickly, whereas if it was a low current, my electrons would be moving through it really slowly. Now, again, when we're talking about this, we're mentioning those electrons moving through the circuit. Those electrons are negatively charged. So when we talk about current, we could be talking about it in two different ways. And it depends sometimes where in the world you have come from, which way you define it. We actually use both ways for the NYP and diploma. So in this case, we talk about conventional current. Now, conventional current was before they actually knew anything about electrons, and they always said that current went from positive to negative. So this was all before they actually knew that electrons existed. They said charge, current must move from the positive side to the negative side, and they knew that something was flowing through there. And that's what we call conventional current. So conventional current is positive through to negative. Well, actually, we know that electrons are not going to move towards a negative because same charges repel. So in this case, electrons actually flow from the negative terminal all the way around to the positive terminal, okay, because they're attracted to the positive. So opposite charges attract. So electrons, once they discovered them, they actually found out that current actually moves from the negative towards the positive. But scientists were a little bit lazy and they didn't want to change all their way of describing things. So that's why we have these two different ways to describe current. We have the old method, which basically helps us with a lot of our physics calculations. And then we actually have the real way that the electrons move, which is the negative towards the positive. So going back to the definition, we said it was rate of flow of charge. So rate, remember, means divided by time of charge. So current is actually charge divided by time, which makes sense. It's how many electrons, so how much charge that those electrons are giving, and over how fast that they're doing it, so over the amount of time there. So in terms of like symbols, we actually use the letter I to represent current. Okay, now current is represented by the letter I. Charge is represented by the letter Q, and time is represented by the letter T, little t. Okay, that's the symbol. So that's if I was just drawing these out and I would say I is equal to current. We actually have a unit of measurements, okay, and these are a little bit different. So for this, current is measured in amps or amperes. Okay, and that's represented by the letter A. So I could say, for example, I is equal to 5 amps. That says current is equal to 5 amps. So rather than having to write current out each time, I just like to use that little I because it's much, much quicker. Okay, so amps is the measurement. Like time is measured in seconds. I wouldn't say it's gone by 5t. I'd say it has 5 seconds. Now charge, okay, is by coulomb, okay, which is represented by the capital letter of C. Okay, so again, if we're using this, we can use our formula, so I is equal to Q over T, or I can use a triangle. I'm not a big fan of the triangle, but I know it helps some of you. So again, if I'm looking at Q is equal to I times T, okay? I is Q divided by T, and T is Q divided by I. I was told when I was learning this at school, this meant you could quit physics because Q is equal to I times T. Or you could do I is a QT, okay? I is a QT, very cute, because we love physics. So if you hate physics, you could quit it. If you love it, you could be I is a QT. I don't know, it's really terrible, but it helps people remember them. So there you go. So going back to current, so I forgot to mention a little bit there before, but essentially when we're measuring current, okay, we measure it with an ammeter because current is measured in amps, okay, and we put our ammeters in series in our circuits, okay. Series means it has to be in the same loop, so I could put it in different places. I could put it down here, I could put it up here, but it has to be in the same loop as the device I'm wanting to work out the current for. Okay, so we add it in series, so it goes in the same loop. Okay, so going back then to our equation, all right, we are going to do a couple of little practice questions just to make sure we can solve for this. So we have Q is equal to I times T, I is Q divided by T, and T is Q divided by I. So going on to our next page, I've got two little quad problems here. So first one is how much charge has passed through a resistor in 1 minute if the current is 2 amps? So the first thing I always do is I write down my equation, okay? Q is equal to I multiplied by T. The next step, I'm going to add in my values. So I'm going to say, okay, that means I've got 2 amps times 1 minute. But I have to suddenly look at this and I think, I've made a mistake. 1 minute is not the correct unit. Time should be in seconds. Okay, so in this case, I've got to say that I've actually got 2 times by 60 seconds. Okay, so 2 amps and 60 seconds. So sometimes it's useful to put in your units to make sure you don't make a mistake where you need to change them. Okay, so 2 times 60, so that means I've got 120 coulombs. Okay, so using that capital C there for coulombs. And usually just to make it nice and neat for your teacher, underline your final answer. Okay, so get into the habit, show your equation, add in your values, check if you need to convert or change any of your units there, and then 4, give the answer with the unit. Make it really clear for your teacher. I know as a teacher, it really annoys me when I have to start looking through a student's work to try and figure out what they mean what the answer was. So the next one, this time round, we're going to find out the current. So what is the current when 5 coulombs of charge has passed in 3 minutes? So again, this time round, I want to work out current. So I'm going to use my I is a QT equation. So I is a QT. In this case, I've got 5 coulombs of charge divided by 3 minutes. Again, can't have my time in minutes. I've got to change it into seconds. Okay, so I'm going to have 5 divided by 3 lots of 60. Okay, so I should have done times 60 there. I don't know what I was writing. Let me just write that again. 5 divided by 3 times 60. Okay, so in this case, that's going to be 5 divided by 180. Again, if I just put that into my calculator, so if I go to 5 divided by 180, that gives me 0.027777, carrying on. And I don't like that. We don't give our answers like that. Okay, so what we're going to say is that is equal to 0.028, okay, using it to kind of 1 or 2 significant figures in this case. And then I'm going to make sure I've got my answer in amps. Okay, so in this case, I can also put that down like so. All right, so again, making it really clear. So again, going for the steps, I've written my equation, I've put in my answers, I've checked, do I need to convert? I did. Okay, and then I'm going to write my final answer with my unit. All right, so again, making sure that my answer was given in amps. And that's a little bit there on current and charge. Let me know again if you do have any other questions.